Hello everyone, this is Muhammad Fahim bin Amin. If you have watched the previous video, then you have understood that there are two types of different data types in Java. One of them is the primitive data type and the other of them is the reference type. Alright, now in this video, I'm going to talk about the primitive data type, and in the next video, in the next video of this video, I'm going to talk about the newer data type. Actually, that's not newer, that is the reference type data type. All right, so let's start. So now it's the time to show you how primitive data type works and how you can use them in your code based on your need. All right, so first of all, we have the byte, B-Y-T-E, byte, and this takes 8 bits in size. Let's say I'm gonna declare a variable, so the data type is byte, and let me name it something like byte variable, and let me store something like this. And if I simply want to print these variables value, then obviously I can do it like this. All right, so there goes our byte. And in the next we have short. So let me simply declare it. So short, and let's say I'm gonna name it something like short variable, and I'm gonna keep 78 here. The only difference between this short and the byte data type is that short is double in size than byte. How is that? Byte is 8 bits, whereas short is 16 bits in size. That means double than byte, right? And then again, if I want to print this variable's value, then easily I can simply call the variable name, and there it goes. Next we have integer. We use int as the short form for integer, and integer is 32 bits in size. So let me simply write it down here like this. So whenever we want to print, or whenever we want to use any variable for storing integer value means numerical value but without any fractional value, or you can say without any radix point between them. All right, so in those cases we use integer. Let's say I'm gonna keep it like integer age equal to 24, and I can simply print the age like this. So cool, right? But as you can pretty much understand that this 24 is very short number, so I can simply keep it using byte. So the better way to do it would be using byte, because I don't need integer to store only 2 digits here. But whatever, I'm gonna show you all of the processes step by step so that you can understand what you need to do in your cases. All right, and let me show you something more. Let's say I'm going to declare another integer variable like integer another variable. All right, and I'm gonna keep some value like 1 2 3 4 5 6 7 8 9 10 like this. You see that this number is too large, so I can't store this large number into this integer data type. In that case, I need to use long. What is the difference between integer and long? Long is 2 times more than in size. Long data type is 2 times more than integer data type. All right, now let me simply change the data type to long, and let me simply add that here long, and that is 64 bits in size. That means long is double in size than integer data type. Right, now you see, even though I have changed the data type from integer to double, this still detects it as a large number. Why is that? Is it wrong? No, it's not wrong, but here's a thing you should understand. In Java, whenever it gets any numerical digit, it detects or it thinks that as a typical integer value. All right. So to explicitly specify that it is not an integer value, rather than that it's a long data types value, we use L after the digit. And here you can use a small l or the capital L. Anything would be fine. But you see that if we use a small l, sometimes it looks kinda similar like small like 1. So I would recommend you to use capital L instead of using a small l. But obviously that's your choice. All right. Now, if I want to print that, obviously I can do that like this. All right. Now, you might have another question in your mind. Let me show you something real quick. Let's say long new data equal to, I'm gonna store 1 2 3 4 5 6 7 8 9 like this. All right, let me simply increase the value something more like this, and capital L to indicate that it's an long data types value. Cool, right? Now you see that whenever we want to write this number in other places, for example, let's say I'm gonna simply copy and paste a number here, we face difficulties reading this number altogether. So in that case, we use comma between them like this, and this. It makes it easier to read this out, right? But in programming language, specifically in Java, because I'm talking about Java right now, you can't use comma like this. But there's an option that you can use, and that is using underscore. Let me show you something. Now, let's say I'm simply gonna removing L just to show you what I am changing between these numbers. I mean among these numbers, right? So let's say I want a comma here after before here and before it, before 6 and before 12. And let me simply add the L again. Now you see it looks kind of readable than earlier, because normally whenever we want to read something like this, we use comma, as I have just told you. But in the programming language, as we can't use comma, we can use underscore to specify that there is comma or something like that, to understand what the actual value is or how long the actual value is, right? And if you want to print that, obviously you can do that, no harm in there. Let me simply run it again. You see it right here, right? And you won't see any impact of this underscore, I mean of this additional underscore in your code. You can use the same thing in the integer as well. Let me simply declare another integer. So let's say another integer value, and let me simply write something like this, and I can simply add this, and if I want, I can simply print that integer value like this. This works, right? This is working. And there goes our long data type. And now you might have this question in your mind that whether you can use fractional value or not. Yeah, obviously you can use that, because in our normal life we use fractional value frequently. So why can't we use that in a Java programming language, right? Now let me simply show you how you can do that. For short fractional value, we use float, right? And float is 32 bits in size. So let me simply declare a float variable. Let's say float fractional value equal to something like 56.987. And if I want to print that, I can print that. But here you see that it's detecting that as error, or you say kind of error. It's telling me that the record type is float, but I have provided double. Why is that? Because I think you have remembered, because I have said just a few moments ago that whenever we want to use long data type, we use capital L or small l just after the value, because Typically, it normally detects that as an integer data type. The same thing happened here as well. By default, Java thinks that this is a double data type because normally double contains more data, more bits than float. All right. So if we want to use the float data type, after specifying the value, we have to use a small f or capital F. As earlier, I prefer the capital F. Cool, right? But you won't see any impact of this capital F in the value. I mean, if you calculate or print the value, you won't get to this capital or a small f. Let me simply show you real quick. You see, it's breaking. Now let me simply increase this value something like this, and if I simply use an underscore here, that would also work. You see, no additional impact for that. Now here goes our double. And in the next, we have, sorry, there goes our float. And now I'm going to talk about the double. And double is 2 times more in size than float. So double is 64 bits in size. Let me simply declare a double variable. Double, let's say double value. And let me simply declare something like this. And I can simply print the value like this. So it's working. As I have increased the value too much, I am getting an engineering notation after it. E to the power 12, that means into 10 to the power. E to the power 12 means 10 to the power 12, most probably. I'm not sure because I had used it too much ago, I mean too long ago. But if you see any differences in the data, make sure to let me know in the comment section. All right, and now I'm gonna talk about character. So character is 16 bits in size, 16 bits. Let me simply declare a character variable. So let's say character data equal to capital F. Remember that whenever we want to work with character data type, we have to use single quote. You can't use double quote. All right. Now, if I want to simply print the data, I can do it like this. Cool. And last but not the least, I have Boolean data type. All right. And Boolean is 1 bit in size. Let me simply declare a Boolean data, I mean Boolean variable. Let's say Boolean b equal to true. And keep in mind that Boolean data type's value can either be true or false, nothing else. It only contains one of these two values, true or false, right? Let me simply declare another Boolean data type. Let's say Boolean v equal to false. And if I want to simply print it, I mean print a value for v, I'm getting false. So here you go. In this video I have talked about some mostly used primitive data types in Java, but I know that this is a completely introductory video. So whenever I will show you more processes, more codes, I would expand all of the knowledges based on these data types. So don't worry about that. And if you want to follow me, you can do that in GitHub, GitLab, LinkedIn, Facebook, Twitter, Instagram. I'll provide all of the link in this video description box. If you want to support me, you can buy me a coffee. And yeah, that's it. Thank you everyone, and I will see you in another video. Till then, take care.